Welcome back, and now let's get to factoring completely. We have now learned the 5 rules of factoring, and we're going to apply them. Anytime you're asked to factor, you need to break the expression down as far as you can go. So let me show you what I'm talking about. Here's my expression, 2y to the 4th minus 4y cubed plus 2y squared. The directions say factor completely. When we're going to approach factoring, the first thing we always look for is the GCF. If there's something in common with all the terms, we must divide that out. Well, if we look, 2, 4, and 2 can all be divided by the number 2. Y to the 4th, y cubed, and y squared can all be divided by y squared, the lower exponent. So our GCF is 2y squared. We take that out, and we say what's left. 2y to the 4th divided by 2y squared is y squared. Negative 4y cubed divided by 2y squared is negative 2y. 2y squared divided by 2y squared, term divided by itself is 1. We need to write that 1 because it's connected by addition. Now, here's the problem. You're not done factoring. Inside your parentheses, you have 1, 2, 3 terms. 3 terms is called a trinomial. So when we're looking at this list, these rules of factoring, GCF is done for as many terms as you have. But if you only had 2 terms, you would look at difference of perfect squares. If you only had 3 terms, you would look at trinomial. If you had 4 terms, you would look at grouping. Because there are 3 terms here, we're looking at the trinomial rule. In my world, trinomials are easy or difficult. This one is easy because the coefficients are understood to be 1. So we know to factor trinomial, we put 2 sets of parentheses. Trinomials always factor into 2 binomials. We're going to do backwards FOIL, so I'm going to write my letters to help me out. Starting with the first term, what multiplies to y squared? Y times y. Then I go to the last term. What multiplies to 1? Well, that's easy. 1 times 1. Now let's check. Will these numbers, 1 and 1, add to 2? Sure they will. If you say add, the symbols have to be the same, the signs have to be the same, and adding to a negative makes both these terms negative. Now don't forget your GCF, 2y squared. You have to bring that down. Remember, factoring is like listing all the ingredients. Now, are we done? We look inside the parentheses. I have a y minus 1. There's only 2 terms here. So if it's 2 terms, I would look at the rule difference of perfect squares. I have the difference, but are both these terms perfect squares? Well, 1 is a perfect square. It's 1 times 1. But the letter y is not because it's y to the first power, and we said to be a perfect square, the exponent's got to be even. So that's how we know this is completely factored. It's broken down as low as it can go. It doesn't fit this rule. Now, another rule that has to do with 2 terms is the sum or difference of perfect cubes. Even though I have it listed in position 5, it has to do with just 2 terms. I have it listed last because it's the one we use the least. So is this a difference of perfect cubes? Well, again, it's got the difference sign. 1 is a perfect cube, but to be a variable that's a perfect cube, your exponent has to be a multiple of 3. And the exponent of 1 is not a multiple of 3. So that's how we know we're completely factored. Now, if we move on to my next expression, m to the 4th minus 16. Again, I want to factor this completely. This time I want you to notice, do you see a GCF? No. GCF is always the first thing we look for, but not every algebra expression has a GCF. So there's not anything we can divide both of these terms by. Because there are only 2 terms, we look at 2 rules, difference of perfect squares or sum or difference of perfect cubes. To do trinomial, you need 3 terms. I don't have that. To do grouping, I need 4 terms. I don't have that. So let's go through the list. Is this a difference of perfect squares? Well, it has a difference. A perfect square needs an even exponent. I have that. And 16 is my perfect square number. If you know your list, 1, 4, 9, 16, 25, we said it. To factor a difference of perfect squares, we put 2 parentheses. It's going to be the 2 binomials that are conjugates. So m to the 4th is m squared times m squared, and 16 is 4 times 4. 1 gets a plus, 1 gets a minus, conjugates. Now we keep going. We look here, we have m squared plus 4. It has 2 terms. So I'm thinking it's either difference of perfect squares or sum or difference of perfect cubes. It is not a difference of perfect squares. It doesn't have a subtraction. It is not a sum of perfect cubes. Even though it has a sum, 4 is not a perfect cube, and the exponent is a 2. That's not a multiple of 3. This expression does not fit any of these rules, therefore it does not break down. If you remember, this is called a sum of perfect squares, and that can never factor. So we leave it. Our next expression, m squared minus 4. Again, there's two terms in here. So I'm either looking at difference of perfect squares or sum or difference of perfect cubes. It's got a difference. M squared is a perfect square. It has an even exponent. 4 is a perfect square. It's a number times itself. So perfect squares factor into two parentheses. It factors into two binomials that are conjugates. M squared is m times m. 4 is 2 times 2. One gets a plus, one gets a minus. I look. Can I factor any more? I have two terms in here. That's a sum. So if I have two terms in a sum, it needs to be perfect cubes. Well, 2 is not a perfect cube, so we're done with that. I have two terms in here. It's a difference. Is it a difference of perfect squares? No. 2 is not a perfect square. Is this a difference of perfect cubes? No. 2 is not a perfect cube. If you know your list, you'll know 2 is not on either perfect square or perfect cube list. Therefore, that's in lowest terms. So here is the expression factored completely. Hope you enjoyed it.